Okay, so today we are looking at measures of variability. Okay, variability. This is what I would write down. Variability equals consistency. See? Okay, variability equals consistency. That was the best synonym that I could think of yesterday. So, if I have a high variability, like on this one, the middle one, would that mean that whatever it is that we're looking at would be more consistent or less consistent? What do you think? What do you think, Laura? Yes. So this would be less consistent. Okay. If it's got a low variability, like on this one, we would say it is more consistent. Now, it doesn't necessarily mean it's one's better than the other. What it means is we just have to look at this and analyze it more carefully. If we're looking for consistency, then yeah, the more consistent one would be better. But if you're just trying to figure out, what is the max number or something, lowest number, we don't care about that part. So today we would measure variability by calculating the range and the interquartile range. All right. So those are the two numbers we're going to be looking at and then deciding whether things are consistent, less consistent, based on their variability. Okay. So let's look at some graphs. All right, we've got histograms. You guys remember histograms? We got two different histograms here. So if I'm looking at this chart A, histogram A, would you, and you have a bunch of these on your homework tonight, okay? Would you say that this has a high variability or a low variability? Based on what you just wrote down. High variability or low variability? It's one or the other. Which one do you think? What do you think, Lorelai? What? Which one was high? Was it more consistent or less consistent? Less consistent. Look at this right here. Here's what we will use to determine. Let's calculate the range. So the range on this, I don't care how tall these are. Don't care about all that. All I care about is from the smallest number to my largest number down here on the number line, on our x-axis. So that goes from 40 to 70. So 40 to 70 is a range of how many? 30. Let's look at histogram C then. Its range would be what? It goes all the way, well, 20 is right there, so I would say it would go anywhere from 10 to 90. So its range is, what's its range? 80. All right, so now when you're looking at these two, which one would you say has a lower variability? What? The first one has a lower variability. This one, A, is more consistent. It has a lower variability because its range is smaller. All right? And it throws people off on these because they see the taller bars. They think, oh no, well, we're not worried about how tall the bars are. We're worried about how spread out the data is. So see how A's data is less spread out on the x-axis? That's what we're focusing on. Yes. Yes. Does it make sense? Everybody? Yes, no, maybe so? The ones that are paying attention? All right, so we're looking at cell phone users. What can this tell you about it, the cell phone users? What does this tell us about 3 different cell phone users? Look at it, not the magazine in front of you. Look at the graph and tell me what you think. This tells me about 3 different cell phone users. We've got sample A uses their cell phone anywhere from 0 minutes a day to over 300. So we'll say 300 plus minutes a day. Their average amount of time is somewhere in this middle 50%. So anywhere around 175 to 225. So that's sample A. Sample B, the smallest number of minutes they use their cell phone is 125. The most they use their cell phone is 275. You know they're going to use it somewhere around 190 to 210. Then we've got sample C. That person is guaranteed to use their cell phone almost 150 minutes to 250 minutes a day. Most likely they spend 200 minutes on it. So what does this tell me? I know. Could spend the most minutes on their phone. The blue could spend the most time on their phone because they have before, based on some data right here. Because if we look right here, this is just the probability of their phone usage, right? So the blue one could spend, but they could also not use their phone at all. The other 2 people use their phone every day, right? So who would you say is on their phone the most? Is that, can we determine that from this? Well, this person, the person in the green sample, is most consistent, right? This one is the most consistent. And so that's really all we can tell on this, is that the consistency. You can't really tell any more about this other than, now, if they were shifted, if they weren't all sitting peaking at about the same point, then we could analyze it a little bit more, but that's all we can tell on this. We got some box plots, or box and whiskers. So don't look at all this over here. We don't care about that. We want to look at the range and the IQR. So the range on this first one, sample 1, goes anywhere from, we'll say, what, 22 is the highest, down to 0, 1, somewhere in there. So the range on this first one is 22. What's the range on the second one? It goes anywhere from 22 again to negatives. So we'll say -3. So what's the range on that one? What? 25. Okay. The other thing we could use is the IQR, the interquartile range. You should be paying close attention on this because this is where I lost people yesterday. That is from one end of the box to the other end of the box. So that is what, 10 to 16-ish? So that's a range of 6, an interquartile range. So that means that middle 50% is within 6 units. We don't know what these values represent, do we? So we would say they're within 6 units of one another. On sample 2, your IQR goes from, what would you say, 3, 2? No, that's above 5. Sorry. 7. We'll say 7 to just below 15. We'll say is 14. So sample 2's IQR is 7. All right. So now, based on the range and the interquartile ranges, you would tell me which one has a lower variability or more consistent. Which one? Which one has a lower variability or more consistent? You only got 2 options here. Come on, people. What do you think, Bree? Which one is that? The first one you would say is more consistent or has a lower variability. How many people agree with Bree? She is correct. Yes, because it's smaller range. Now, it's close, isn't it? It's not a huge gap, but it is a smaller range. So that's what we're doing today. We're looking at these. Which one has a lower variability? M or B? Lower variability. You should be able to tell just by looking at it. Which one, Bailey? B, right? Now, anybody know what these dots are? This is just a fancy box and whisker. But why does it put dots above? You got these dots right there. What are those for? Anybody know? These are what we call outliers. Okay, outliers are data points that are lying out there by themselves. Sometimes they will, if you've got a large set of data, if you've collected data from millions or even thousands of people, you're going to take the top few data points and the bottom few data points and you're going to throw them out. In this case, they took the top 3 and they just made them separate dots and showed that those 3 would throw off the rest of my data. If I was to put that in with the rest of my graph, it would throw it off because it would bring up the average way too much. Okay, so sometimes you throw out outliers, but you still show them with a little asterisk off to the side, somewhere in there. In this case, they use little dots. And so what we're going to be doing over the next couple weeks, the last few weeks of school, is we are going to have a question. I'm going to throw a question at you. And you guys are going to test something. You're going to, we'll go outside, we'll test it, we'll record our results, then we'll compare our results with our classmates, and we will make some graphs, and we will make some conclusions using mean, median, mode, range, interquartile range, about our data and about our question that we originally started with. Okay, so you're going to have to create some of these graphs. You're going to have to be able to analyze and determine what it tells us. All right, so make sure you're paying close attention on these. Let's look at this. Okay, here was the situation I threw out earlier. I said, which of these has the lowest variability? Which of these, box and whiskers, has the lowest variability? That means it would be the most consistent. Amir, which one do you think? Three, you would say, is most consistent? Right, three would be the least consistent, right? Least variable. So the lower variability is more consistent. So we would say this one has a low variability. This one has the most variability, right? Or a high variability. Now, does that mean that method 2 is the best? We don't know what these are methods for. We don't know what we're scoring, do we? So let's say we are trying to train our dog to go potty. All right, we're trying to train our dog to go potty. Well, which one would you say is the best method for training your dog to go potty? What do you think? Liana, which one would you choose? Pick one. Which one? If we're trying to train our dog to use the restroom, which of these methods would you think is the most successful? What? So you're saying method 3? What made you think that? You're just thinking that the bigger the graph means better in this situation? What? Because it would be the most consistent? Okay. Could be. It's a trick question. We don't know what these numbers are still for, do we? Are we recording on the side the score, the 10, 15, 20, 25? Is this how many times the dog went to the restroom where we wanted it to or had an accident? We don't have enough information here, do we? So let's say this went outside where we're trying to get it to go. So now, Liana, your method 2 would be the most consistent. So whatever you're trying to do to get your dog to use the restroom outside, method 2 would be the most consistent. That could be the best method. Anybody else have any thoughts? What? What are we missing? I think, yes, you would want to know more, like, what are these methods maybe? You know, if one method is more successful than the other, but it's super expensive, you might not, or one is more dangerous. You might, what?
Like if you train them to go outside too many times, then they might get confused. So I don't know. If you do it too little, then
I want my dog to go outside every time. I don't want it to use the restroom in my house ever.
you're gonna make them go outside.
Right.
When they don't even, how are you supposed to know?
I mean, if it's an accident, yeah. I mean, okay, so you got to train your dog. That's what we're testing different methods to be more successful to get my dog to go to the restroom outside. Okay, so I recorded the results. This was method 1. We don't know what we did, but we know this is method 1. It went outside. The median number was 25 times. So we would just use that as an average because we don't have an average on this. You can't calculate the average from these. So we'll just call that my middle is my average. Method 2 has a lower variability, but its middle number is still around 25. This one, I get my dog to go to the restroom outside 30 times was the middle number. And this one was what, somewhere in the 32, 33 range. So which one was having the most success getting my dog to go to the restroom outside? Which method, Matt? Method 4 would be probably the most successful because look also at this middle 50%. This IQR is also getting more results, right? We're getting the results we desire in that. Now, is it the most consistent? No, but that might not be what we're looking for here. Whereas consistency is good, I still want to get my dog to use the restroom outside. So I'm getting more of the results I want here. Whew. Man, who knew reading graphs and charts was going to be so thought-provoking, so annoying, time-consuming? Yes, there's really a lot to look at on these. We got some dot plots. So these represent how many people had 0, how many people had the number 1, how many people had the number 2. So we've got these 2 dot plots. Mrs. Hampton's 6th grade class. Would you say it has a high variability or a low variability? What do you think, Lorelai? High variability? Depends on what we're talking about here, right? We're talking about test scores. Yeah, they're kind of spread out. We'd like to see a group further down here. What's this one? What do we call that? And come on, people, starts with an O. What? An outlier. Remember? That's an outlier. It's lying out there by itself. So we call it an outlier. So if this is test scores, and this person either refused to take it or would not miss school and then wouldn't come in to do it during their lunch or whatever, you would throw that score out, because I wouldn't want that to bring down the average of the class scores, would I? But there's extenuating circumstances. If I'm looking at this and I'm trying to figure out whether my kids understood the material, I wouldn't want to calculate an average on a kid that refused to take it, because that doesn't reflect whether he understands the material. Now, if he really took it or she took it and got a 0, then, but still there's got to be a reason for that, and that I've got to address differently than the rest of the class. Right. Yeah. So what about these? Which one is more consistent? Which one has a lower variability? Class A or Class B? Class A or Class B? Which one has lower variability? So if I'm looking for the range, I go from 4 down to 14, right? So the range on this one is 10. The range on this one goes from 3 to 9, which is 6. So which one has a lower variability, Bailey? B has a lower variability because its range is smaller. Class A's got something going on where they've got like 2 different groups of people in there, don't they? So we'd have to go and look at that a little bit more detail as well. All right, so this is what we are doing, is we are looking at range, interquartile range, to determine the variability. Rest of the time is yours to work on your digits assignment.